In part 2 of this series, we're asked, the portion of the parabola y squared is equal to 16x between x is equal to 0 and 16 is rotated about the x-axis. Find the area of the surface of a revolution generated. So we are expected to find the surface area generated according to this function. Since it's being rotated about the x-axis, we need to take this equation and solve for y. That way it's exclusively in terms of x. So let's start by solving for y. We get y squared is equal to 16x. That's our original function. Square rooting both sides, we end up with y is equal to the square root of 16x. The square root of 16 is plus minus 4, and the square root of x is simply that. So now we have our function exclusively in terms of x, and we've done that by solving for y. Next, what we will do is find the derivative of this function, and then substitute that into there, and this function into here. Taking the derivative of this isn't hard to do. We have y is equal to 4 times the square root of x, and there's no need to add this plus or minus because our function is opening up both in the positive and negative. We have to change the square root of x into x to the power of half, which means the same thing mathematically. So y is equal to 4 times x to the power of half, and we'll use the power rule. That means that we will take this half and multiply it to the x and subtract the exponent by 1, giving us 4 over 2 times x to the power of negative half. X to the power of negative half is the same thing as 1 over the square root of x. So let's write that in. Remember, 4 over 2 is 2, so 2 over the square root of x. Now we have everything we need to substitute it into that formula. That formula again was surface area is equal to 2 pi times the integral between 0 and 16 for the function y, 4 times the square root of x, times the square root of 1 plus the derivative squared dx. What I would like to do first is, before I take the integral, I need to clean up the integrand as much as I can. You see this 2 and the square root of x? It will become powered by 2. So this becomes a 4, and this part right here will lose its radical, giving us the following. 2 pi, that part hasn't changed, times the integral between 0 and 16. And one other thing that I'll do is I'll make this 4 as a square root of 16. That way I can combine the 16 and the x to become the square root of 16x. This expression and this expression mean the exact same thing mathematically. And there's a reason why I'm doing this, because surface area problems like these will usually result into very difficult integrals, as you're going to see here. So by using these tricks, it makes the process a little easier. This part has become the square root of 1 plus 4 over x dx. Since this factor and this factor are both being powered by half, they both have the square root around them, we can combine the radicands. So this 16x and this can be combined or multiplied. Here's how. 2 pi, and I will introduce square brackets just so that we don't have to worry about the 2 pi later on when we find the integral. 0 through 16, we have 16x, this part times this part. 1 plus 4 over x, all square rooted, dx, close the square bracket. 16x times 1 is 16x. 16x times 4 over x is 64, plus 64, the square root dx. We still haven't found the integral. We're just cleaning it up. Now we can start finding the integral. What I will do is set 16x plus 64 as u. I know a lot of you will maybe factor out a 4 here and then pull it all out completely. You can do that, but we'll just set this as u and find it out this way. U is equal to 16x plus 64, and I'll take the derivative of this implicitly with respect to x, giving us du is equal to 16 dx, where dx is equal to du over 16. Now we have 2 pi times 1 over 16, because technically I would be replacing this dx with du over 16, which is 1 over 16, and I would be pulling it out anyway. So I've pulled it out, and this has become the integral between 0 and 16, the square root of u du. What's the integral of the square root of u? Let's do our work over here. U to the power of half. To find the antiderivative, we add 1 and divide this sum by it, which is 1 over 2 plus 1, 3 over 2, giving us 2 times u to the power of 3 over 2 over 3. At the same time, I will replace this u back with what I set it as. We found the integral. We have 2 pi over 16 times 2 times, what did we set u as? 16x plus 64 to the power of 1.5 over 3 when x is 16 and 0. Now we can use our calculator to do the rest. Let's substitute 16 into here, into all of this. We get 2 times 16 times 16 plus 64 to the power of 1.5 divided by 3, 3,816.22. And now we will set it at 0, where we get 2 times 16 times 0 plus 64 to the power of 1.5 divided by 3. That's equal to 341.33. Whatever this is equal to, we multiply by 2 pi over 16. So 3816.22 minus the answer we just got times 2 pi divided by 16 gives us 1,364 units squared. 1,364 units squared, and that is the surface area of this structure. There you have it. That is how to find the surface area of solids using integrals. Make sure to watch part 3 where we tackle one more example.